Hi everybody, I hope this video finds you well. In today's video, we're going to be finishing up our discussion of descriptive statistics for categorical variables. In the previous video, we spent a little bit of time sort of talking about two major ways of organizing data for categorical variables. Those were the frequency table, sometimes referenced as the actual frequency table, and the relative frequency table. We also talked about two visual displays for categorical variables. Those were the bar graph and the pie chart. In this video, we're going to take a little time to look at another example of building some of those organizational tables and those displays, as well as working a bit with a categorical variable. And then we're also going to take a look at a type of categorical variable that we don't work with nearly as much in this course, which is a categorical variable where a single individual can be placed into multiple categories. Again, that second example is not going to be something we're going to see very frequently in our class, but I'd like you guys to at least have seen it once to be aware of it. So let's get into these examples. Let's suppose that there's a researcher that wants to study Americans' favorite sport to watch at home. So to study this, the researcher first divides the country into 5 major regions. So there's the West Coast, East Coast, Midwest, South, and Southwest. The researcher then randomly selects 100 people from each region to take their survey. So if you're selecting 100 people at random from each region and you have 5 major regions, of course the researcher ultimately selected 500 people to take their survey. The first question on the survey asks, what is your favorite sport to watch at home? And they give the options of basketball, baseball, football, soccer, hockey, or other. Notice that this question is saying, what is your favorite sport to watch at home? So this is a more standard categorical variable for us because each individual is only going to be able to give a single response. You have to pick one category to put yourself in because it's your favorite sport. Notice here it says that the researcher gets 368 responses. So while they did send it out to 500 people, only 368 responded. The researcher then organizes these responses according to the following relative frequency table. So you'll notice that the information we're being given in this question is a little different than what we did in the previous video. In the previous video, we were given sort of the raw data. This time, we're actually already given to us in a summarized form, which is the relative frequency table. So here are the categories: basketball, baseball, football, soccer, hockey, and other. And here's the percentage of people that landed in each category. 22.8% identified basketball as their favorite sport, 19.8% identified baseball, 23.6% identified football, 10.3% identified soccer, 16.8% identified hockey, and 6.5% identified some other sport. So we've got a few things we'd like to do with this. First, we'd like to do our standard sort of diagnostics. We're going to identify the population, sample, and individual in this situation. And in B, we're going to identify the sampling technique used to build the sample. So these are the sort of basic diagnostics that we covered back in the basic definitions part of our class. Then we're going to take this relative frequency table and construct the actual frequency table. So instead of saying the percentage that landed in each category, we'd like to actually say how many people were in each category. Then we're going to construct a bar graph using the relative frequencies, so using these percentages. And then we'll have a couple sort of follow-up questions just actually working with the data here. So let's start by talking about the population, sample, and individual. So we'd like to talk about the population, the sample, and the individual here. So again, I always sort of recommend trying to identify the sample. Who did you actually collect data about? Well, we know that you collected data about those 368 people who responded. So our sample would be those 368. You could just say people, you could say responses. I guess if you wanted to be really specific, you could say 368 Americans, since that was their sort of telling us where we drew them from. So 368 Americans. What's the individual then? Well, it would just be one American or one person, and the population would be all Americans. That's who we were trying to study, and we're hoping that those 368 people that we actually talked to in some way sort of represent all Americans across the country. All right, let's talk about B, the sort of technique that was used. Well, if we go back up here and take a look at this, we can see that they mentioned that they randomly select people. So we know that this was done randomly, so that tells us it could be an SRS, could be a stratified sample, could be a cluster sample. It's definitely not convenience because it mentions random, and it's definitely not systematic because, again, it mentions random rather than talking about a system like choosing every 20th person or something. So which of those is it then? Is an SRS a stratified a cluster? Well, notice that initially the researcher divided the country into 5 major regions, and then they selected 100 people from each region. So in other words, they basically performed an SRS for every one of these 5 regions. Because there was that initial classification, or the fact that they took several SRSs and put them all together, this would be a stratified sample. So the technique here was stratified. And the strata, if you wanted to make note of that, was the sort of region that the people were from. And of course, that might be important to somebody who's trying to study sort of your favorite sport to watch, because sports might be sort of regional. Certain regions might like one sport more than another. So it's important that every region of the US was sort of represented in our study. So in this case, the researcher used a stratified sample to build their actual collection of data. All right, let's get into the actual analysis then, trying to construct the actual frequency table, the bar graph, and then doing a little bit of work with this. So we'll give ourselves a fresh sort of page to sort of work with here. I'm going to keep this data though, right up here. And let's go ahead and talk about how we would build the actual frequency table. So for C here. So, you know what, maybe I think it might be a little nicer, instead of doing that, let's just give ourselves a completely sort of fresh page here, and that'll be a little bit better. And we'll just grab this part right here, just bring that data over. Okay. All right, so let's go ahead and pop that up there just so we can reference it. Okay. All right, so what we want to try to do is, for part C of this, we'd like to come up with the actual frequency table. So that means we need to have all of our categories listed, so each of the sports, so basketball, baseball, football, soccer, hockey, and other, and then how many individuals fell into each category. So how are we going to do that? Well, in the previous video, we spent some time talking about how to go from frequency to relative frequency. We said that when you had a frequency and you wanted to turn it into a relative frequency, you divided by the sample size. Well, in this case, we want to reverse that, so we need to multiply by the sample size. So what we would do is we take each of these. Remember, whenever working and trying to do arithmetic with a percentage, you need to convert it into a decimal first. So we would take this first one, convert it into a decimal, which would be 0.228. Go ahead and multiply that with the sample size. Remember the sample size back here. If we go back all the way to when we first did that, we said it was 368 Americans, or it was the 368 responses. So that's what we'll go ahead and multiply by. We'll multiply by 368. So if we go ahead and do that multiplication on a calculator, 0.228 times 368, you should get something like 83.904. Of course, the frequency is an actual number of people, so it has to be a whole number. So we would say that that comes out, nearest whole number, 84, because it's 83.9, so we would round to 84. So what that means is that 84 people out of the 368 chose basketball. That gives us that 22.8%. All right, this other should be the same. So we have 0.198 times 368. If we do that, 0.198 times 368, you should get something like 72.864. If you round that to the nearest whole number, 73 people chose baseball. 0.236 times 368. If you do that, 0.236 times 368. You should get like 86.8, which would round to 87. For soccer, we would take as a decimal 0.103 times 368. So 0.013 times 368. 37.9, that should round to 38. Then for hockey, we'd have 0.168. Once we write that as a decimal, times 368. 0.168 times 368 should give us 61.8, which we would round to 62. And then finally, the other, keep in mind if you make that a decimal, you'd move it twice, and you get 0.001. 0.065, so it would be a 0 in front, and then times 368. So 0.065 times 368, you should get 23.9. That would round to 24. If we want to do a quick check, if we sum all these up now, if we actually total these, so 84 plus 73 plus 87 plus 38 plus 62 plus 24, you'll notice that the total is now 368, which makes sense. When we add up the percentages, we should get a percentage that's basically 100% up to rounding. I believe if you add these percentages, you'll get like 99.8%, which is fine. I mean, it's just a rounding concern there. Here, when you add up the frequencies, it has to total up to the sample size, which is at 368 there. So there we go. There's the actual frequency table. Again, you want to be comfortable having both of these. You want to make sure you can find the frequency table and the actual frequency table. If you remember, we've talked about how if you start with the frequency table, division will take you back to the relative frequency table. And now we've seen that multiplication will take you from the relative frequency table to the actual frequency table. Okay, well, let's go ahead and build ourselves a visualization of this. So for D, I believe we wanted to construct a bar graph, and we want to use the relative frequency. So we want to use these percentages for our vertical axis here. So this will be a relative frequency bar graph. Keep in mind, you can use both the actual frequencies or the relative frequencies when building a bar graph. You just have to read what's being asked for. So in this case, we'll go ahead and make our vertical axis based on these relative frequencies. Notice the percentages go from as low as about 6% to as high as 23.6. So it might be nice to go by something like 4 or 5% at a time. Remember, you do need to have your bottom start at 0%. So this will be the relative frequency. Always make sure to label your axes as well. I'll go ahead and just go by 5%. So my first mark will be 5%. Then 10%, 15%, 20%, 25%, and that's sufficient because, of course, my highest one is 23.6. All right, so we'll go ahead and we'll sort of fill these in. So there's basketball, baseball, football, soccer, hockey, and other. Okay, and so this is favorite sport to watch. And do keep in mind, again, bar graphs, main rule, bars cannot touch. That helps the viewer know that you're talking about a categorical variable as opposed to a quantitative variable that we'll be discussing in sort of our next set of videos. So for the first one, we need the basketball one to reach a height of 22.8. 22.8 should be somewhere up here, somewhere between 20 and 25. Again, we just want to do the sort of best job we can. So maybe something like about that. Okay, for baseball, we want to go to 19.8, which would be just below the 20%. Okay, for football, we want to go to 23.6, which would be just a little bit beyond the basketball one. For soccer, we want to go to 10.3%, so just barely over the 10% mark. For hockey, 16.8, so we want to go a little past the 15%. And then for the other, 6.5%. So there we go, something like that. And again, if you want, you can sort of write in those percentages. This was 22.8%. This was 19.8%. This was 23.6%, 10.3%, 16.8%, and 6.5%. So there we go. There's a bar graph showing us those relative frequencies. Notice that this basically would help us see that football seemed to be the one that got just barely the highest percentage of sort of choices, right? Just over basketball. Baseball sort of was a close runner-up to these two. Hockey was sort of a little bit lower. And then, of course, soccer and the other category were significantly lower from this. So again, main point of a bar graph is to help the viewer sort of compare category against category. Okay, let's answer a couple more sort of follow-up questions from this. So for E, the question that was asked is what percentage of the sample chose either basketball, baseball, or football as their favorite sport to watch from home. Key thing here is that whenever you see this or, and you're talking about somebody choosing this category or this category or this category, or mathematically always indicates addition. So all we're going to need to do this is sum up the percentages for each of these categories. So to do this, we want the percentage who picked basketball, baseball, or football. So again, the sort of tip off here is when you see that sort of or, that usually indicates in mathematics an addition, because you're saying how many were in here, how many were in here, how many were in here, and we want to put all those together because we don't care which one they picked as long as they picked one of these three sports there. So we have the percentages already. They were given to us back up here, that 22.8, 19.8, and 23.6. So we can add those together, 22.8% plus 19.8% plus 23.6%. We add all those together, 22.8 plus 19.8 plus 23.6, which would give us 66.2%. So 66.2% of our sample chose basketball, baseball, or football. So these three sports combined for 66.2% of all the people surveyed. So that means close to 2/3 of all the people that were asked, 2/3 is about 67%, picked one of these three sort of main sports. Sometimes these are referenced as the big three in US sports. So they made up almost 67% of all the sort of votes for those three categories. All right, we've got one other sort of quick follow-up questions. Just make sure that we're comfortable working with this. For F, we say how many people in this sample did not choose hockey as their favorite sport to watch from home. The main thing I want to call attention to here is the sort of wording. Notice it says how many people. Very different than what we did in E. E is asking for the percentage, which meant that we wanted to use the relative frequency. For F, it's saying how many actual people, meaning that we want the actual frequency here. So this is telling us that we want to use the actual frequency. And we want all the people that did not choose hockey. So let's go ahead and do that. So for F, how many people did not choose hockey? Well, there's two ways we could do that. We could simply go through and add up everybody who did not choose hockey. So that would be basketball, baseball, football, soccer, and other. We could add all those together. So approach 1, and this would certainly work. You could take 84 plus 73 plus 87 plus 38 plus 24. Add all those together. 84 plus 73 plus 87 plus 38 plus 24 would be 306. That's totally right. A faster way to do it, and maybe a slightly more clever way, would be to say, okay, we want all the people who did not choose hockey. We know we had 368 people overall. We know 62 chose hockey. So we could simply do this as 368 minus 62, which would be 306. Either way, you achieve the same answer there. So we can say 306 people in our sample did not choose hockey. Okay. Later on in our class, we'll get to talking about probability, and we'll see that this approach 2 here actually gets sort of a fancy name. It's called the complement rule in probability, and it basically says that if you want to figure out the probability of something not happening, you can look at the total probability minus the probability that it does happen, which is exactly the same idea we're doing here. We're saying if you want to figure out how many people did not choose hockey, you can take the total number of people minus the people who chose hockey, and that gives us everybody else. So there we go, right? The point of this sort of example here was first to, again, just make sure we're comfortable with those sort of basic diagnoses, population, sample, individual, as well as the sort of sampling technique. That's sort of the fundamentals of the sort of language we're building together here. Then we also talked about how to convert from relative frequency to actual frequency. So if you put this together with the previous video's example, you now know how to go back and forth between actual and relative frequency. We built one more visual display, which was a bar graph, this time based on the relative frequencies. All that meant is that we did the percentages as the vertical axis. And then we answered a couple of just sort of data-driven questions, the percentage of people who landed in one of three categories just by summing the percentages, and the actual amount of people who did not choose a particular category. The only thing I really want you guys to sort of pull out from E and F here, of course, is that E, by asking for the percentage, meant that we needed to use the relative frequencies, and F, by asking about how many people, meant that we needed to use the actual frequencies there. Okay, this pretty much wraps up the major analysis that we need to do right now for descriptive statistics for categorical variables. Before we call it good on categorical variables, though, I would like to look at one example of a categorical variable similar to the one that we just talked about, but where people are allowed to put themselves in more than one category. And we'll see that it sort of limits the amount of things that we can do, but it can lead to some interesting results. So we're going to continue our example, and we're going to suppose that on this same survey that we were just analyzing, the researcher also asks a second question. Now keep in mind, remember, we're still assuming they sent it to those 500 people and 368 responded. The second question, phrased a little bit differently, says, which of the following sports do you watch at home regularly? Basketball, baseball, football, soccer, hockey, other. It seems very similar, but keep in mind here, the big difference is that you're not asking them for their favorite sport. You're actually asking them for any sport that they watch at home regularly. So, same categories, but sort of a differently phrased question. They organize these responses according to a frequency table, or an actual frequency table. So here's the data here. 159 people said basketball, 101 said baseball, 152 said football, 56 said soccer, 93 said hockey, 58 said other. Okay, first thing we should notice here, if you sum up these frequencies, you are no longer going to get 368. Why is that? Well, somebody might answer this question and say that what do they watch at home regularly? Basketball, baseball, and hockey. That means that they gave 3 responses. It's no longer going to be a one-to-one correspondence between the amount of people and the amount of people in each category. So we have to be very sort of careful with this. So the first thing we're going to do is we're going to try to construct a bar graph for this data based on these frequencies. So we should still be able to do a visualization of this. So let's go ahead and grab this, and then we'll go on to the next sort of page here. Okay, so we'll give ourselves another page to sort of work with here. So there's our sort of data. Okay, so for A, we'd like to do another bar graph. So let's give it a better name. It's an actual frequency bar graph. So that means on the vertical axis, we're going to use the actual frequency. Okay. Notice that the lowest actual frequency was like 50 and the highest was 159. So we need an axis that will help us sort of see that. We could go by like 25s, 25, 50, 75, 100, 125, 150, 175. You could go by 20s or 50s or something like that. Whatever you sort of choose, as long as you start at 0 and have a consistent scale. So I'll just go 50, 100, 150, 200, which should be sufficient. All right, so then we'll have basketball, baseball, football, soccer, hockey, and other. This is a sport you watch regularly. So that's a different sort of question there. All right, so for basketball, we should draw it up to 159, which should be somewhere probably right about there. There we go. For baseball, it was 101, so right to about 100. For football, it was 152, which should be right about there. For soccer, it was 56, so maybe right about there. Hockey, 93. And for other, it was 58. There we go. All right. Again, if you want to, you can put those frequencies inside 159, 101, 152, 56, 93, and 58. So there we go. There's our actual frequency bar graph based on the amount of people that landed in each category. Okay, well, let's see if we can do a little bit more with this. So I think for B, we had a question here. We wanted to say, what percentage of the sample said they watch soccer regularly? Now, this is an interesting sort of question here. We have to be sort of careful with this. We're saying what percentage of the sample? Remember, the sample is those 368 people that we asked. So we want to know what percentage of the sample said they watched soccer regularly. So we will take that 56 and divide by that 368. So for B here, percentage who said they watched soccer regularly. So we'll take the 56 out of the 368. 56 people said they watch soccer regularly. There were 368 people who responded. We'll put that as a, that looks sort of ugly there, sorry. We'll go ahead and we'll get that as a decimal on our calculator. And so you should get about 0.152. Good rule of thumb in this class is to round your decimals to 3 decimal places. So we've got 3 decimals. And then, of course, that gives us a percentage with 1 decimal. So 15.2% of our sample said that they watched soccer regularly. Now, you might say, could we go through and do this for all of them? For sure, we could easily go through and get the percentage for each category that watched each sport regularly. Keep in mind, though, that if you added those percentages up, they would no longer add up to 100% because some people could be in several categories. So while we can calculate these percentages, they don't operate like the standard relative frequencies would because some people might be in several categories. But we can certainly still use this to say that 15.2% of people who were asked this survey question responded that they watched soccer regularly. Notice that if we go back and compare that back here, 10.3% of people identified soccer as their favorite sport, but a higher percentage identify it as that they watch it regularly, which should make sense. Having something be your favorite sport is a more stringent sort of condition than just watching it regularly. There are certainly things that we might watch regularly that we don't consider our favorite here. So it makes sense that the percentage that identify it as their favorite is lower than the percentage of people who just say that they watch it regularly. All right. Speaking of that, sort of the differences in how these sort of questions can lead to different conclusions, let's take a look at C. In C, it says, according to the first survey question, according to the first survey question, which sport was the favorite for Americans to watch from home? According to the second survey question, which sport was the most popular for Americans to watch from home? So let's take a look at this. Let's go back to the first survey question and think about which was the favorite to watch from home. If we go back here, we can sort of look either based on the frequencies or probably more easily on the relative frequencies. Football just narrowly won out over basketball as the favorite sport to watch from home. 23.6% of people chose football as their favorite. Now, is that true when we just switch the question from favorite to watch regularly? Well, if we go back and look at our new data, right, when we ask them which of the following sports do you watch at home regularly, you'll notice that basketball just barely edges out football. So notice that by changing the sort of style or just how you phrase the question from favorite to watch regularly, you can get a different sort of conclusion here. So what we would say is we could say in the first question, football was the favorite sport, but in the second question, basketball was the more popular sport. And the reason I want to call your guys' attention to this is for a couple reasons. One, this relates directly back to one of those motivating examples we talked about. I gave you guys an example about how the sort of Colgate toothpaste company got in trouble with advertisements because in their survey question, they asked a question more similar to this, like, which toothpaste do you recommend, in general? You can pick as many as you like, but they phrased their conclusion more based on what is your favorite brand of toothpaste. So it's the same thing here, right? If you ask what is your favorite sport, it seems like football wins out. But if you just ask what do you watch regularly, basketball has more regular viewers. So what's sort of interesting about this is that this could, if you were using this as actual research, it might tell you something about these sports, right? It might tell you that football has some very, very diehard fans. People who like football might really, really like that sport, whereas basketball might be more sort of open or casual to viewers, right? People might not pick it as their favorite, but more people in general watch it. Now, does this necessarily apply to the US as a whole? Well, this was only 368 people, so certainly that's a decent sample size, but we'll have to learn more in our course to really learn how to extend results like this, and also to figure out how confident we really are in making estimates and predictions from these results. For right now, though, I just want you guys to sort of be comfortable working with categorical data and understanding the difference between a question where people put themselves in a single category versus a question where somebody could put themselves in multiple categories. In our next video, we'll be changing gears, and instead of working with categorical data, we'll begin to discuss how to work with quantitative data.